Good morning, everyone. Thank you all for coming here today. What I like to present to you today is our new approach to coke strength and reactivity prediction. This presentation aims to discuss a new approach to the prediction of coagulability on the basis of feed coals properties. The special emphasis was put on the chemical, rheological, and petrographic single coals and coal blend analysis. All above-mentioned analytical values were correlation with the coke reactivity (CRI) and strength (CSR), and this provided Higgs correlation coefficient. Results were taken into account for future investigation. In this respect, on application of all-maceral mean reflectance as a threshold for determining reactive portion of maceral in the sample and simultaneously measure vitrinite reflectance has proved to be a useful tool for both tape and rank determination. Contrary to the maceral analysis that is basing of the subjective operations evaluation, the scan analysis provides an objective identification independent of human eye. This subjectivity influences the identification of the reactive portion of inertinite group of maceral and the accuracy of the reactive inert ratio evaluation. 138 individual coals of the vitrinite reflectance between 1.00% and 1.13% show a positive correlation with CSR and CRA values. 11 samples fitting the coking coal range provide to be compatible with the CSR and CRA values. Next step of investigation was designed to test the possibility of application of maceral scan analysis for the coke strength and reactivity protection of the base of the semi-industrial coal blends. The carbo tests were completed of the 11 coal blends that were subject to chemical, rheological, and petrographic analysis with the special emphasis of the all-maceral scan analysis and vitrinite reflectance. The mean random reflectance values of all samples were within the range of coking coals. The carbonized coal blends were subject to the CRI and CSR tests. The results were a subject of regression and the multi-dimension correlation of CSR test and calculated. 15 industrial-scale coal blends were composed of there, 4 and 5 coals, and were subject to the chemical, rheological, and petrographic analysis. The proximate analysis results are in concordance with the carbonization system requirements, and so are their coking properties. Their vitrinite reflectance range from 1.05% up to 1.36% and is characteristic for the coking coals. Accordingly, all maceral reflectance varies between 1.17% and 1.37%. Sum of reactive maceral is no lower than 15% and the Higgs value reaches the level of early 63%. Both petrographic and selected plastic values were applied in the regression formula for prediction of the Coke strength and reactivity. The obtained results have provided that both test and calculated CRI and CSR values are very close. This gives an impact to carry out tests on the full industrial scale. Third step, the procedures took place again at Trineckie Żelazarne coking plants according to the schedule given below. The discussed coke characteristics are as follows. The moisture content does not exceed 4%. Ash in few cases slightly exceeds 10%, and volatile matter only in one case reach to value approach 2%. Both micum results are fairly regular. Micum 14 oscillate around 18 and micum 10 varies between 5.6 and 8.1. Attention draw CRI and CSR values obtained by test and compare with values calculated from the petrographic formula. Sum reactive was determined by the mean reflectance threshold plus minus 1/2 class of the mean reflectance values. The result of multiple correlation between CSR test and CSR calculated values was even better and reached the correlation coefficient value of 1.971. The multiple correlation between CRI obtained by test and that calculated have reached the multiple correlation coefficient values as high as 0.958. The presented scan method for the determination of the reactive portion in the feed coal by use of the scan mean reflectance threshold and the worked out formula for the coke strength and reactivity protection is a new original approach to the coke quality problem. The above present results have confirmed the applicability of all maceral scan reflectance in carbonization processes. The use of the all maceral scan method based on the maceral reflectance provides results that are independent of the human subjective evaluation. The conformity of CRI and CSR industrial coal values with the calculated ones allows to use of petrographic calculation for the coal blend's composition. The high correlation coefficient between CRI, CSR, and the calculated ones have been achieved for the coal blends that were carbonization under fully industrial condition. This allows the suggested that the petrographic calculation method could be introduced in the coking plants for the routine coke quality predictions.